I would say that our best bet is to either find, I've got some geometry finals
Cool.
in my computer, or reviewing algebra,
Cool.
which is something else they usually do. You guys actually had a period where you were reviewing algebra
Yeah.
a while back.
Uh-huh. It was a little while, yeah.
Problem with me reviewing algebra and me picking out the algebra is algebra is a huge topic.
It
So
is.
I really wouldn't know where to begin
Yeah.
other than find an algebra final here or algebra problems that we could work on. But let's see
Right.
what I've got in the way of geometry.
Cool.
I got, well, let's see. I think Ryan K. had a final now. Wrong one. Hold on.
You're good.
Julian. Pretty sure Julian had a final. That would have been his first semester final, though.
Okay.
So that's not probably going to work because your
Yeah.
first semester final isn't what you're going to be reviewing.
Yeah.
Let me see if I can find a final exam here.
Cool.
Morgan. I worked with Morgan a lot. Let's see. I can tell by dates. What we want are problems from the second semester. You know, there's a May 19th. This ought to be review material for geometry.
Yeah, definitely.
Well, it's circles. You can't get away from it no matter how hard we try.
Yeah.
Let me try, though. I really feel like there's better stuff for us to be working on than circles. Let me, just because you did so well with circles.
Yeah.
Transformations. I don't think that's what we want to do either. Hold on.
Okay. Cool.
Just a second. Let me see if I can find
Sure.
a better problem there. Let's see
Sure.
what they were doing. Oh, that's what they were doing in February.
Yeah.
Dilations and transformations. I don't want to review that because it's not that you might not need to know it. And certainly if you get this on your review material, we will review it.
Definitely.
Dilations are not part of the geometry that you need for the ACT or the SAT.
No.
Do not get into dilations in the same way that they don't get into the circles either.
Right.
So, I mean, they get into some circle questions, but not this business of the angle from a circumference being half of the arc length. They don't really get into arc measurement very much.
Yeah.
That's in the realm of geometry that you need for geometry class, but you don't necessarily need any time after that. So
Right.
I would rather we do stuff that is more general geometry. Now, you are going to have to be able to do medians. You know what a median is of a triangle?
Yep. Oh, I don't. We haven't really done that.
Well, a median is the line that goes from a vertex to the middle of the opposite side.
Okay.
That's
Yeah,
what.
I do remember that actually.
Okay. And
So
if
the
you
median.
draw all
Yeah.
three medians in a triangle, they will intersect at the same point. And that will be the centroid, I believe.
Okay.
As far as You did incenters and orthocenters and circumcenters and centroids, right?
Uh-huh.
Or
We
not?
have.
Okay.
Yep. Yeah, we did.
So if this is a median and Fy is 4, what's Wy?
8.
Okay, that was tough. Uh,
Cool.
all right, number 6. Number 6 is a case where they have drawn 3 medians
Mm-hmm.
from each vertex. And notice they do cross right there,
Mm-hmm.
and that is the centroid. And there is something about the centroid, and there's a formula that says that BZ is 2/3 of the distance from B to X.
Okay.
Okay, so here they're giving us CA, they're giving us XA,
Yeah.
and they want us to solve for X. Okay, well that's not that hard. Here, let me open up my other window here, just a second.
Sure. Definitely.
Let me get everything. Wow, let's close that one out.
Cool.
Close the circle one out. Well, go ahead, what?
Oh, I was just saying, do you think we could just do a half hour tonight? I just have, my English teacher decided to slam me over the weekend with,
Sure, no problem.
this huge worksheet. It
Yeah.
stinks. I've been working out of the past hour and a half.
That's fine.
Okay. I appreciate it. It's just,
Works well for me also tonight. I've actually had a
Okay,
really busy day today. It was wide open, and then all of a sudden I got a lot of late appointments.
wow.
But,
Yeah, that's
okay,
good for
let's look
business.
at number 6.
Okay.
Okay. Each of these 3 lines is a median.
Mm-hmm.
And they're telling us what CA is. It's 5x minus 4. They're telling us what XA is. It's 3.
So you just, right. So you just set them equal to each other, right?
Almost.
Almost.
It's not CX and AX.
No.
If it were, you could set them equal to one another. But what's
they're
the
not,
relationship between XA and CA?
XA is half of CA.
All right, let's start there. XA is 1/2 of CA.
Mm-hmm.
You always need a starting spot to solve a math problem. And
Yeah.
I just can't overemphasize enough the fact that you're looking for an equation to write that you can solve.
Right.
That's all of these are like that.
Mm-hmm.
So XA is, I can substitute 3x minus 4.
Yep.
And CA, I can substitute 5x minus 4.
That makes sense.
Here's a good algebra problem for us to solve. What's next step?
Definitely. So it'd be 3x minus 4 is equal to 2.5x minus 2.
There's only one problem doing it that way.
Mm-hmm.
You introduced a fraction.
Okay.
There's no need to introduce a fraction.
Okay.
What can I do to make this problem simpler as a first step?
As a first step, we could...
My 2 rules are get rid of denominators, get rid of parentheses.
Right. So could you multiply the parentheses by 2?
Yeah, if I multiply, not the parentheses, multiply both sides of the equation by 2.
Yeah.
Well, if I do that, I'm going to get rid of the parentheses and the fraction at the same time.
Cool.
Now what's the left side?
6x minus 8 is equal to 10x minus 8.
Hold on. I've got 1/2 times 2 times 5x minus 4.
So it'd be 2 over 4.
No.
Or 2 over 2.
The reason I multiplied both sides by 2 was to get rid of that 1/2.
Right.
I'm left with whatever is 5x minus 4. Now, this is a whole lot simpler than what we started with, because what we started with had a fraction in it.
Yeah, for sure.
We don't really want to introduce fractions by distributing. In other words, you definitely have a choice here. A lot of people would have chosen to distribute that 1/2 instead of multiplying by 2. And it would work. It's just then we're left with a fraction that we're going to have to combine with another one, whereas this solves itself almost.
Right.
What's the answer here?
So now it would be 1x minus 8, or x minus 8 is equal to negative 4.
Steps. This is the one place in math where I'd like to see you do both steps at the same time. It's not very often I say that. Usually I say do everything one step at a time.
Right.
But when you are gathering your variables on one side of the equation and all your numbers on the other, just go ahead and do both steps at once. What number is on the right side?
Negative 2.
What do I have to do to both sides to get that 8 moved over?
Add 8, so just be 2.
What's minus 4 plus 8?
Minus 4 plus 8 would be 4. Oh, 4. I don't know why I kept saying 2, my bad. Yeah, so just be 4.
Okay.
Cool.
So, all right, let's look at the next problem.
Okay.
Number 7. If MG, find MG if MS is equal to 36. Well, let's talk about this median thing again. Median is unique. I'm going to go from that vertex to the middle of the opposite side.
Okay.
I'm going to go from that vertex to the middle of the opposite side. I'm going to go from this vertex to the middle of the opposite side.
Okay.
And now the relationship between these segments is the long segment is always 2/3 the length of the full segment. So in this problem, they're saying MS is 36.
Yeah.
And they want to know what MG is. Well, MG, you can see from the drawing, is the longer of the segment. I haven't exactly drawn it proportional, but if something was going to be 2/3 the length of that MS, it would be MG, not GS.
Right.
In other words, if you look at that picture that they drew, you can tell that MG is longer than GS.
Yeah.
So they're not equal. And the relationship is that MG is twice as long as MS, excuse me, as GS.
That's GS, yeah.
Which makes MG equal to 2/3 of MS.
Okay.
Notice that if MS were 30, MG would be 20.
Yeah.
Which is twice as long as 10.
Right.
So it's a 2/3 relationship. It's one of the few relationships in geometry that I can think of that's 2/3.
Yeah.
Most everything is half or double.
Right.
But in a way, this is. In other words, this distance is double this distance. It just makes this distance 2/3 of the total distance. Well, they gave us MS is 36, so 2/3 of 36 is 24.
Cool.
Sorry, the answers are on here also. That's one thing I can't
that's okay.
prevent, but
no problem.
let's see.
I didn't know how to do that anyway, so.
Well, that's good. In other words, your best bet is to follow my drawing on the left.
Exactly.
Let's see. On number 8, they've only drawn 2 medians.
And this one you could set equal to each other because SK is equal, or is half of SE.
No, it's not. SK is how much of SE?
Yeah, that's not halfway.
So let's start with our equation. SK is equal to what?
So SK is equal to 2x minus 2.
Hold on. 2/3. Let's use the most broadest equation we can.
Yeah.
There it is. It's kind of like starting out, when you're talking about circles, you start out A equals pi r squared, or C equals 2 pi r. Start out, if you start out every single problem with the most general equation you can, you'll be a lot better off.
Yeah.
Okay? Because this is what you have to memorize. You have to memorize that when you have medians in a triangle,
Mm-hmm.
that distance, SK, is 2/3 of SE.
Mm-hmm.
Now we can just plug in. Well, SK is 2x minus 2 from their direction.
Uh-huh.
SE
2/3.
is
2x.
2x plus 6. Now let's do this geometry, or algebra.
Okay.
And we
So
don't
we
need
can...
a picture anymore. We've got an algebraic equation. We just need to solve it.
Exactly.
So what can I do to get rid of the denominator?
Multiply both sides by 3.
Yeah, not 3/2.
No.
Because if I multiply both sides by 3/2, I'm going to introduce fractions over here. That would
Right.
get rid of the 2/3 completely.
Mm-hmm.
But if I multiply both sides by 3, I'll get rid of that.
Okay.
Okay, so the left side becomes 6x minus 6. I've multiplied it by 3.
Mm-hmm.
Right side, I didn't get rid of that top 2,
No.
but I did
2x.
get rid of the bottom. But now, much easier equation to solve.
Much easier.
When you can get rid of fractions or denominators, it just looks easier. It's not
Yeah, definitely.
intimidating. And solve this. What's the next line? Do both steps at once?
So it would be 2x is equal to 18, x is equal to 9.
Good.
Cool.
State if the three numbers can be measures of the side of a triangle. And I'm not sure this is something that you and I have talked about before.
Yeah.
But it's a very important principle with triangles. Let me give it to you in full.
Okay.
Any side
Mm-hmm.
has to be less than the sum of the other two.
Mm-hmm.
And there's a second part to this that's just the opposite. And greater than the difference of the other two.
Okay.
So if you can remember the first line, you can always figure out the second because it's just the reverse. In other words,
Yeah.
that's going the opposite way of that, and sum is the opposite of difference.
Exactly.
Okay? So,
Okay.
this has to apply to any side of any triangle.
Mm-hmm.
Okay? So we need to check all three of these.
Okay.
We'll start with 10. Does
Okay.
it fit the first requirement?
Any side is less than the sum of the other two. Yeah. Yeah, that makes sense.
It just
Well,
fits
no,
the
because
second
9 is
requirement.
smaller.
Correct.
So no.
It's not. It's
Yeah.
smaller than 11. So that
No.
cannot be a triangle.
No.
Let me make some up.
Sure.
Can that be a triangle?
It can. Yeah.
Hold on. That is not less than or
Any
equal to. That's less than. And this is greater than.
Oh, I was looking at the first one, my bad.
Equal
Yeah.
doesn't count. And
No.
so, first of all, 2 has to be less than 8,
Mm-hmm.
which it is.
Which it is, yeah.
But 2 isn't greater than 2.
No.
So, no triangle.
Mm-hmm.
All you have to do is fail with one side, and it can
Right.
be a triangle. It might
Exactly.
fail all three sides, and in fact this does. The 3 doesn't pass either. The 3 is
Right.
less than 7, but it's not greater than 3.
No.
And the 5 is not less than 5. So all
Oh.
3 sides fail in my example.
Yeah.
How about this one?
Well, that one definitely, no, that one doesn't work.
Hold on. Before you're so quick to say that,
Yeah.
tell me which side doesn't work.
Um, so we know that, well, we
Just
know that
start on
100
the
is
left.
less.
Start on the left and go left to right.
Okay, yeah. So we know 100 is less than 103.
Okay.
So that one's true. And then um,
What else does that first 100 have to be?
it has to be equal.
No, it has to be less than the sum of the other two.
So less than the sum of the other two.
And it is.
Yep, it is.
But it's also got to be
And
greater than what?
it also has to be greater than 103.
No, the
Is
difference.
that right?
Remember, the second part of it is opposite everything. In other
Okay.
words, this 100 has to be less than 100 plus 3, and it has to be greater than the difference, 100 minus 3.
Oh, I see.
Okay?
So 100 is less than
Yeah.
103.
So that 100
And then
works.
that one works, yeah.
Okay,
And then
let's try
100,
the other 100. The other 100's obviously still also going to work because it's the same
yeah,
other two numbers.
definitely.
So that one works. Now let's try 3.
Okay. Um, so we know 3 is less than 100.
Not 100, 200.
Is it 200? So you just add the other two together
Yeah.
then. Okay.
Any side has to be less than the sum of the other two sides.
Okay. And then we know that 3 is greater than 0.
So this is a legitimate triangle. What does this
So
triangle
that one
look
works.
like? It looks like this. It's an
It'd be a right triangle, right?
It's an isosceles triangle.
Oh, okay.
This side is 3, that side's 100, and that side's 100.
That makes sense.
Okay?
Okay.
So just because you see 3 numbers that are huge, in other words, it's odd. If you ask most people, they would say this is a triangle and this isn't.
Right.
Because these
It
3
is.
numbers are close together. And these 3
But that's
numbers
not
are
the
not.
case.
So you can't use that. You
Yeah,
actually
exactly.
have to test each combination out.
Okay. Cool.
Okay?
All right.
Let's see what else they had on this thing here.
All right.
Let's see. Let me snap left. Blow that up.
I see you've gotten used to the Windows 10.
Well, I am. I'm getting used to it. I don't know if I've gotten used to it. I still don't know how to
Oh,
rotate.
I still haven't.
Do you know how to rotate a picture?
Nope. I still. Oh.
Ah, there's a rotate. But guess what? That button does not show up on certain files. And I
Weird.
think it's the files you send me. There's some either JPG files or some sort of file that a phone camera takes doesn't
Weird.
offer me this rotate button.
Huh.
I mean, I can rotate that. Ooh, it didn't do it. Oh, yes, it did. Okay. Yeah, no,
Weird.
I get some pictures from students that I don't.
Just can't
I
rotate.
check every single button I have available to me, and I can't rotate it. Of course,
Weird.
I didn't know how to expand it either, and you have to edit, and then there's a plus. See, the plus minus shows up only after you hit that button.
That is
You can
weird.
imagine how long it took me to find that plus minus, because
Yeah.
it's invisible unless you hit edit. And now, of
That's
course,
so
you
weird.
blow it up.
Yeah.
But all right,
Okay.
one. All right, let's order. I'm gonna give you a triangle. And I'm going to have you order the angles in each triangle from smallest to largest.
Okay. Cool.
It's the smallest angle.
Angle C.
Next.
Then angle A and then angle B.
Good. Okay. So you understand that The smallest angle has to be opposite the smallest side, and so forth and so on.
Exactly.
This problem over here is just, if I could read it, it gives you the angles and it wants you to order the sides. So that's just the flip side of the coin.
Okay.
Cool. Let me think if there's any last problem that we could work on.
Cool.
Wow, actually I got a hugely difficult problem on my last student. An algebra student gives me a geometry problem that's enormously tough.
Cool.
We don't have time for me to give it to you, but it would be tough to solve regardless.
Yeah.
Well, I guess that's a decent place for us to stop, since I can't make out these other problems.
Yeah.
What could number 10 say? That's a problem itself. Okay, here. Yeah, we can do 10.
Yeah, definitely.
What we have on number 10 is we have two sides of a triangle.
And you just do the Pythagorean Theorem to solve it, right?
No, that's for right triangles only.
Not isosceles.
Well, these don't have to be isosceles. In other
They can
words,
be any
every
type.
triangle you see in this picture is a scalene triangle.
Yeah.
They're not isosceles, they're not equilateral, they're not right. Okay.
Right.
But using the rule that we were just talking about, what's the minimum this side could be and what's the maximum it could be?
So the minimum could be, so
It's got to be less than the sum and greater than the difference.
right, so 7 is less than 12.
No, hold on. We're looking for a third side.
So it'd just be 0.
No, I circled it because that's what we need to fill in. Okay. Would 1 work?
7 is less than 13.
Hold on.
But 7 is not greater than...
In this case, let's just work with this side here.
Okay.
So this has to be less than 19. Has to be greater than what?
It has to be greater than 5.
Okay, so it can't be 5. It's got to be at least 6.
Right.
On the low side.
Yeah, so 6...
How big could it be?
So it can't be greater than 19.
It can't even be 19.
No.
So it can be anywhere from 6 to 18.
Right.
And we were given these two sides. So we don't need to check these sides now. In other words, it didn't ask about that. The question was, what is the range of possibilities for the third side? Well, it's got to be at least 6 on the low end because it's got to be greater than the difference.
And
it's got to be less than 19. So assuming it's all whole numbers, it's got to be 18.
Right.
And you'll notice the answer there was x is greater than 5 and less than 19. That's actually the proper answer because it doesn't have to.
That makes sense.
Yeah, it's got to be greater than 5 and less than 19. So it could be 5.1, in other words.
Yeah.
And it could be up to 18.9. In other words, this tells the answer better because it allows for all numbers, not just whole numbers.
Definitely.
All right. Well, that's a good principle to learn, if nothing else. That principle right there, that is tested. That is tested on the ACT and the SAT. And it's one thing that isn't always taught in geometry. I've had geometry students from beginning to end of year that don't ever come across this relationship about triangles.
Right.
About what a side of a triangle has to be. Just always remember it's got to be less than the sum of the other two, because then you'll be able to figure out the second part of it.
Yeah.
Knowing that it's just the reverse. If it's got to be less than the sum, it also has to be greater than the difference.
Yeah.
All right.
Awesome.
Dylan, I'll let you go and go work on your English homework.
Definitely. Thank you. I appreciate that.
All right. Talk to you next time.
Sounds good. Thanks, Mr. Cal.